Hello, and welcome to this short video, which will show you how InnerOrbit phenomena and questions can be used to assess student growth and mastery on NGSS performance expectations, also referred to in this video as PEs. InnerOrbit is a site where you can find engaging, real-world phenomena. These are accompanied by scaffolded questions that you can use to build any type of assessment you might need for your classroom. These assessments will provide detailed reporting so that you can adjust instruction, assess mastery of NGSS science standards, or prepare students for high-stakes district or state science assessments. Today, we will dig into how InnerOrbit phenomena can be used to assess NGSS performance expectation MS ESS 11. This is a foundational middle school, MS, Earth and Space Science, ESS performance expectation. Content related to this PE is often taught at the beginning of a unit about Earth and the solar system. Students who demonstrate understanding of this PE will know specific DCI or disciplinary core idea content about the universe, Earth, and the solar system. They'll also apply that knowledge by doing the SEP, the science and engineering practice of developing and using models. And all of this will happen through the lens of the CCC or cross-cutting concept, using patterns to identify cause and effect relationships. These three dimensions of the PE come together, requiring students to develop and use a model of the Earth-Sun-Moon system to describe the cyclic patterns of our lunar phases, eclipses of the sun and moon, and seasons. Now that we're familiar with the performance expectation, let's take a look at how InnerOrbit phenomena can be used to assess understanding. Because our goal is to leverage phenomena to engage students in making sense of the world around them, rather than simply memorizing facts and representing knowledge, it's best to select phenomena for assessments that have not been discussed in class. This ensures that students have opportunities to transfer the knowledge they learned by applying it to something new. Students must be authentically uncertain, but also able to make meaningful connections to the problem or phenomenon. Complex information is presented in coherent and accessible ways thanks to an intentional, grade-appropriate mix of text, figures, diagrams, data, and graphs, depending on what the students are being asked to do. But how can you as the teacher know that a correct student answer on an InnerOrbit question is aligned to the NGSS performance expectation you're trying to assess? Let's use the phenomenon we selected, why doesn't the sun set during the summer solstice, as an example. Students are introduced to a phenomenon that most people on Earth will never experience, a pattern of 24 hours of daylight. The midnight sun occurs in places like Barrow, Alaska, where residents will observe the sun circling just above the horizon for many days in a row without ever fully setting. Students will identify patterns in the figures and use models to explain how and why this phenomenon occurs. Ultimately, we want students to complete rigorous tasks and answer complex sense-making questions, such as the one seen here, to determine if they have mastered this performance expectation. Breaking down this free response question about the midnight sun will help us get an even better understanding of phenomenon to performance expectation alignment. This question asks students to develop a model to explain what causes some parts of the world to experience this phenomenon of the midnight sun. Further, they must be sure to show which parts of the Earth might experience this phenomenon and why, based on patterns of the position and movement of objects in our solar system. By breaking down the question, we could clearly see how it leveraged the phenomenon and required students to engage in the DCI, SEP, and CCC dimensions of the NGSS performance expectation, making it truly three-dimensional. But we also know that some students may struggle to answer rigorous three-dimensional questions like this for a number of reasons. This is why InnerOrbit breaks down the three dimensions of the NGSS to create questions that scaffold the student journey towards making sense of complex phenomena. Let's take a closer look. One-dimensional questions, called core content questions on the site, assess the DCI only. Again, this is the what scientists know dimension of the performance expectation. You can see here how question tagging in the teacher view on InnerOrbit provides information about what specific knowledge is being assessed by this question, based on its alignment to the performance expectation. Taking a closer look at the prompt, which of the following best explains why we experience different seasons here on Earth, we can see that students cannot answer correctly without accessing their knowledge about the universe, Earth, and the solar system, to come to the conclusion that the tilt of the Earth on its axis and its position in orbit cause energy from the sun to reach the Earth differently during different times of the year. Two-dimensional questions require students to apply either the science practice or the cross-cutting concept, in addition to their content knowledge, to answer correctly. Here, the question asks students to specifically identify a pattern in the figure, which compares hours of daylight in different parts of North America during the summer solstice, and apply their knowledge of Earth's tilt on its axis to explain the pattern in the figure, that the number of hours of daylight will increase as you move further north. Finally, three-dimensional questions require the use of content, practices, and concepts, whether they are multiple choice or free response. Here, students would need to use Figure 2 as a model, addressing the SEP of developing and using models, and recognize the patterns in Figure 1, hitting on that CCC of using patterns to determine cause and effect, to confirm that location 3 would be the most likely to experience this phenomenon of the midnight sun during the summer solstice. This is due to the tilt of the Earth on its axis and how that orients the northernmost parts of the Earth towards the sun, touching on that DCI content knowledge. On InnerOrbit, you can find multiple phenomena for every NGSS performance expectation, and you can use these three question types to build any type of assessment you want. After you've assessed your students, you will have access to detailed three-dimensional data so that you know where kids are excelling and where they might be struggling. Thank you for joining us for this detailed walkthrough about how InnerOrbit phenomena can be used to assess NGSS performance expectations. Please reach out to our team if you have any additional questions.